Hey guys, it's Miss Carlson again. Hopefully you're having a happy Halloween and enjoying your day off, and whether or not you're going to trick or treat or dress up in a costume. Hopefully you're taking advantage of your time, maybe even watching your notes today. Who knows? So we're going to talk about chemical bonds, which is covered in chapter 6 of your textbook. And there are two types of bonds. One is ionic and one is covalent. And we are going to start off talking about ionic bonding, which is when electrons are transferred between a metal atom to nonmetal atoms. What they have a tendency to do when we have ionic bonding is to form crystal lattices due to that strong attraction between those opposite charges. The strength of that bond is going to be dependent upon the arrangement of the ions, the size of them, as well as their charge. And over here is a picture of a salt cube, which is made up of many tiny little crystals. Now, salt is formed from sodium, which is a cation or a positively charged ion, and chlorine or chloride, which is a negatively charged ion known as an anion. Together, they form salt. Now, dot diagrams are used to help you determine how different atoms will bond with each other in ionic bonding. This is a picture of phosphorus, which has 1, 2, 3, 4, 5 dots in its diagram. And hopefully you know what those dots represent because you know what subatomic particle is involved in bonding. What do you think it is? I hope you said electron. So phosphorus has 5 valence electrons in its outer shell, and that's what is represented in a dot diagram. Now, atoms are stable with guess what number? 8. 8 is the special number, or the octet rule, which says that an atom is stable and it won't react anymore. Now we can determine the number of valence electrons by the group number in the periodic table, as well as electron configuration, and both of these things we're going to get into more detail in class. Now, when we take a look at covalent bonding, this is usually between two metal atoms, but they share electrons to form molecules, and a molecule is just a neutral group of atoms formed by one or more covalent bonds. And the reason I say it's neutral is because it isn't bonded necessarily by charges, but it is bonded by the attraction of shared electrons and their protons, again because of that opposite charge. They're controlled by electronegativity. The electronegativity is the ability of an atom to pull electrons towards itself. And this leads to polar versus nonpolar molecules. And the more polar a molecule is, the stronger that bond is between those atoms. So increased electronegativity equals increased polarity, which will give you a stronger bond. Now, how do we determine polarity? Well, polarity is going to create the separation of charge known as a dipole. And the stronger the electronegativity of an atom, the more negative it's going to be when it's bonded with a weaker electronegativity atom, which would then create a slightly positive charge. So we take a look at the electronegativity number of the atoms to determine if they're going to be polar or nonpolar. So if I were to take a look here at hydrogen and fluorine, I know that fluorine has an electronegativity of 4. And I know that hydrogen has an electronegativity of about 2.2. I know this because I've looked at the table of electronegativity a lot, and I've memorized those ones. So you'll always have a reference sheet to kind of figure this out. But if you look here, if the electronegativity is equal or a difference of less than 0.4, then that molecule is nonpolar, and therefore we wouldn't have a dipole. But in this case, the difference is 1.8, therefore we do have a separation of charge. And because fluorine is so much stronger than hydrogen in pulling electrons towards itself, it will have a slightly negative charge, designated by the symbol here, the Greek letter and the negative symbol. And then hydrogen is going to have a slightly positive charge because it doesn't have as much as electrons as fluorine does on its side. Okay, now we're going to talk about naming compounds. The first thing we need to do is break down what is in front of you right now, which is a chemical formula. Chemical formula identifies the elements involved in the compound as well as the ratio of the elements, usually by a subscript, that little 2. So that tells me that I have one magnesium because there's no subscript next to it, but chlorine, there are 2 of them in this compound. Now, if there is a number in front of the compound, that is a coefficient. The coefficient just tells you the number of that molecule. So there are 7 magnesium chlorides. Now, if we wanted to name those compounds specifically, starting out with the covalent compounds, the most metallic element is going to appear first. And then that second element, you will end the name in "ide." And you will also use prefixes to identify the number of atoms in that compound. So if I were to take nitrogen and oxygen and bond them together, there would be a need for 2 nitrogens and 4 oxygens. Therefore, I would say that is dinitrogen, again, di meaning 2, and tetra meaning 4. So dinitrogen tetraoxide. So oxygen was the second element, and I said the second element you end in "ide." Ionic compounds are named in a very similar way, but you name the cation, remember, the positively charged ion before the anion or negatively charged ion. Anions are normally the metal, and it's going to end in "ide" as well. And if I had sodium and chlorine bonded together in an ionic compound, I would call it sodium chloride, not sodium chlorine. Remember, I changed the metal to that "ide" ending. And that wraps us up for today. Hopefully you took good Cornell notes. Now would be a good time for you to either go back and just jot down some extra things if you missed something, and also form your good questions towards your notes in your Q column. Don't forget to write your summary, and I will see you next week.